Hey everyone, welcome back to part 2 of the Backtesting.py tutorial where I attempt to code this paper entitled Can Day Trading Really Be Profitable? From scratch in Python using the Backtesting.py framework that is found right here, an open source backtesting framework written in Python. So in the last video, we went through a little bit of the documentation, we installed the library, and we got started with a strategy. So all we've done so far is create a new class, a new strategy class called Opening Range Breakout. And this extends the base strategy class that comes from Backtesting.py. So we installed backtesting, right? We imported the base strategy class and the backtest class. We loaded up pandas as we've done many times before. And we have a Colab notebook where we uploaded the TQQQ intraday data that we were able to download from the Day Trading Papers reproduction site. So they posted a blog post where we were able to get a copy of the Polygon data they used. And so we load that into a pandas data frame. We installed Backtesting.py, and then we ran that data frame of price data through the opening range breakout strategy via the backtest class that's just part of Backtesting.py. So instantiate backtest, and then load a data frame, and then run a strategy on that data frame. And we give it the amount of cash that our account balance is initialized with. And we also give it commissions. Now, we didn't add the commissions part yet. I'm going to add that in a moment. We ran the strategy. We discussed how you initialize a strategy. And so we just set a couple of variables where we're going to keep track of the opening range high and low for the first 5 minutes of the trading day. And then we created a next function. And so that's part of backtesting.py. This next function is just gets called over and over again with each bar of data. And so minute by minute, you see we're just printing out each data object that comes in. And so that includes a timestamp that we can access, the open, high, low, and close of the bar, as well as the volume, and any custom like indicator stuff that we pass in. So we have a VWAP here and an ATR value that they had calculated. So at this point, we're just able to loop through the data in order. There's no actual strategy logic. There's no trades being placed. We're just looping through the data. So now what we need to do is actually process this incoming data and put some type of strategy conditions in place, some ifs, thens, elses, different things like that. Maybe run some calculations, some minimums and maximums, that sort of thing, some type of breakout detection. And that's what we're going to do now. So let's get going with that. And if you're new to the channel, I have a website, hackingthemarkets.com, and sometimes I do write-ups of this stuff, and I build a mailing list as well if you want to receive content like this. And so this has all the code that I'm using in the tutorial. And so I'm starting off this part 2 right here at calculating the opening range. And let's talk about what we're doing here. And I think I'm not going to go ahead and type all of this from scratch this time. I want to just discuss what we're adding to this and then run it. So what I'll do is you can copy paste into the Colab notebook, but I'm going to comment things out. That way we show each individual piece. So the first thing we want to do in this strategy, right, is we're trying to calculate the high and the low of the opening range. And so we have minute data already. So we have the minute, the minute that closed at 9:31, 9:32, 9:33, 9:34, and 9:35. And we get minute by minute passed into this next function, okay? And so the first thing we can do is figure out what is the high and low of the first 5 minutes. So we're only seeing these 1 minute at a time. So what I did here, we can access each bar of data with this self.data here. But if I want just the timestamp, I can get the index of the bar that we're on. And the most recent bar is at this negative first index. That's like the last bar we're getting in. And so if I were to print this, I can print the timestamp T here. Okay, and then what we can do, since the timestamp is actually an object here, there's a date function here that we can call, and we can print the date of that timestamp. So I'm going to print the current bar date. So in the last video, we tested just 1 month of data, so January 2016 through February 2016. And this one, since we're going to really be looking really closely, what I'm doing here is just getting a slice of data from January 5th through January 6th, so just 2 days. I want to make sure we can get the opening range high and low from one day, and then successfully detect when the next day comes about so that we can reset the range and calculate it for the next day, right? And so let's just print this out for a single day, just the timestamps. So you'll see here, I'm printing out just the timestamps as they come in. And if I scroll the top here, you see I start on January 5th at 9:31. That's still January 5th. The next bar is January 5th at 9:32, and I just print the date. And then eventually I want some logic that's going to detect when the day changes. So eventually this current bar date is going to switch over to January 6th. And when it does that, we get this minute by minute, and then right here you see, oh, we've switched to a new day. So we're going to need to reset the opening range because we're going to start a new day of trading at that point. And that's the logic I added. And so what I can do here is I created a function called reset range. And what that's going to do is every time the current bar's date changes, we're going to reset the range. And so say that there's a new date at that point. And so now I'm going to comment out this bit right here where we printed the date. Now I'm just going to show you the logic that detects that a new day has happened. And so if I run this again, you'll see just a couple of prints here. You'll just see new date, January 5th, new date, January 6th. So that's the logic for just resetting this member variable, opening range high and low. So we reset that at the beginning of every day, and then we detect when a new day occurs. And I'm just printing a message just to show that that works. Now that we know that we can reset every time there's a new day, what do we need to do on a new day? Well, in this particular strategy, we're just looking at the first 5 minutes of the day. We mentioned that we can get a timestamp associated with the current day, and then we can get the date associated with the current day. So if I just want the time piece of that date time object, what I can do is use t.time. So I have this t object here. I call it t.time, and that'll get me just the time element, okay? And so let's pretend, once again, I'm going to print t.time when a new date happens, just to show you that. And so if I run that, you'll just see the time on its own, so 9:31. And in Polygon 9:31, that stores the price data from 9:30, the very open, till 9:31, so the end of that day. So that's the first bar of data that comes in. If you're using interactive brokers, it'll actually timestamp it with 9:30, and the 9:30 timestamp represents 9:30 through the close of 9:30. Okay, and so what we're going to do here is we're going to keep incrementing, right? And so every time a new bar of data comes in, we want to build up what the opening range is. So we're going to say, what's the latest high of the next minute coming in? What's the next high of the next minute coming in, and so forth, and also keep track of the next low. And so what I'm going to do is, while the t.time is less than the last minute bar in the opening range, which we have configurable right now, we're within the opening range. And so what I did up here is I said the opening range minutes we're keeping track of, we want just the first 5 minutes. And then the last minute bar of the opening range is 9:30, the open of the day, plus opening range minutes, so 9:35. And so while this timestamp here is less than or equal to 9:35, we're inside of the opening range, right? And so now if I run that, you'll see it says the first bar of the day, and it'll say 9:31, it's less than or equal to 9:35, 9:32, less than or equal to 9:35, and so forth, right? So we capture the different data bars as they're coming in from 9:31 to 9:35, and then likewise, a new day comes around, and then we capture that again. So now those are the timestamps we're looking at. Now let's look at the actual price there. So what we can do here, I'll uncomment out this part. So what happens here, 9:31 happens, opening range high and low are none since we started a new day. So if it's not none, we do this. Otherwise, we do this. So obviously, the first minute comes in. The high of that first minute bar is going to be the high of the opening range because we don't have any other data yet, right? And so we just say opening range high is the most recent minute bar's high. And likewise, the first minute bar of the day, the low of that minute bar is going to be the opening range low at the beginning, right? Then the next time this comes around, we're going to have a new minute bar that comes in, and opening range high is no longer none, right? Because we set it to the high and the low of the previous bar. And so now that it's not none, we're going to get the maximum of whatever the last opening range high was and what the current opening range high is. And if it's higher, that's going to be the new opening range high. And likewise, the minimum of the current bar's opening range low, and the previous opening range low is going to be the low, right? And so we're just, as we're looking at each bar that comes in, each minute bar, we're keeping track of a new high and low and getting the maximum high and the minimum low, and we're keeping track of it in this member variable opening range high and the member variable opening range low. And then we don't want to continue doing anything while we're calculating the opening range high. There's no trades being made during the first 5 minutes of the day. And so here I have a return. And so if we're less than the last minute bar in the opening range, right, then we just return and we can run the next function again, right? And then finally, once the current timestamp is actually equal to the last minute bar of the opening range, we can display what the opening range high and low is, because we know it at that point, and then we can continue on to our actual entry and exit logic. And so if I run this right here, you'll see it's going to go through each minute by minute and then tell me at the end of those 5 minutes what the opening range high and the opening range low is. And if I wanted to, I could actually print. So why don't we go ahead and print self.data in here, just so that you see what the data looks like. Okay. So you'll see we have 5 minutes of data coming in, and then you can see how the high evolves over time. So at the beginning, the first minute, it's 108.53, then it's 108.93, which is higher than 108.53, and then you see it's lower, then lower, then lower. So that high was the high of the opening range, and so you see 108.93. Likewise, the low here starts at 108.15, but then it goes down, 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 and finally it's 107.87, and that's our opening range low. And then we go on to the next opening range of the next day. So looks like that bit is working so far. Now, once again, we're not placing any trades quite yet, but we do have the data we need, the signal we need to actually place a trade. So let's go ahead and do that. So if you go to the next bit of my tutorial here, I have one called a section called entries, position sizing, and order placement, right? And you can take that, you can put it in your Colab notebook, and let's walk through that now. This is exactly the same. We have the last minute bar, but we also have an exit minute bar here that I've added as a class variable. And what's the exit minute bar? Well, in the strategy in the paper, it says that if your position is still open at the end of the day and you haven't reached your profit target yet, then you're going to close the position. And so right here, I just created a variable called exit minute bar, and I just set that to 15:59. So it's like the last minute of the day. And what I can do is, as we're looping through all the bar data, I can see, oh, is it the exit minute bar? Is it the last minute of the day? And do I have a position? And if I do, then fire off an order to close the position. So that's all that's for. The next thing we're going to want to store is the current days open. If you'll remember in the paper, what we need to do is see if the close of the opening range is below the current days open or above the current days open, and that determines the direction of the trade. So I created a new member variable called current day open. It's just initialized at none, but every time we encounter a new day, we just store and keep track of what that current day's open is, and we have a reference to it right here, and we're going to use that when we actually enter a position. We've already written the logic right here to calculate the opening range, and we already have this conditional that says when the opening range has completed. And so the way the strategy works is it enters a position at the very close of that 5 minute bar, and then that trade is actually going to execute on the open of the next minute. So the 9:36 bar is when that's going to trade. And so the way Backtesting.py works is exactly like that. So if I place an order here at the end of 5 minutes, it doesn't execute at that exact moment. What it does is queue an order, and then on the open of the next bar, it's going to actually fill that order. And that's to avoid look-ahead bias. So we're not going to get the price at the close of this bar. What's going to happen is actually going to fill at the open of the next bar, which we don't know yet. So we're queuing the order here. And so when right as our opening range finishes, right, we got the 5th minute has come in, we know it's closed, and so we check, are we in the position or not? And so if we're not in the position yet, then we're going to actually place a trade. Now, which direction are we placing this trade? If the close of this current bar, which is the 5th minute, is greater than the current day's open, that means we're going long. So I'll print going long, and we're going to execute a buy order. Now remember, this doesn't actually place the buy. It creates this order object that's going to get filled on the next bar, and I'm going to just store a reference to it in order in case we want to print it out for debugging purposes. For the size here, how many shares we're going to buy, I'm going to talk about that in the next section. So for now, let's just use a fixed size, and then we'll write a position sizing function. And now remember, if that first 5-minute bar is a doji, so the open of the day equals the close of the 5-minute bar, then we're going to do nothing. So no trade is going to be placed. And at the very end of the day, so these bars keep coming in, and then after it's all said and done, if we're in the position and the timestamp is equal to the exit minute bar, so it's the very end of the day, we're just going to close out the position. So at this point, we have a simple entry with a fixed number of shares that we're buying and selling, and a fixed exit of just at the end of the day. And then next, we'll add on to this and calculate a certain number of shares that we want based on our risk percentage. And then we'll also calculate an exit price, like a take profit price and a stop loss price based on the size of the opening range. So let's verify this bit works first. And we're just going to run this on January 5th through February 5th for just 1 month and see what happens. And then what we can also do is print the statistics. So we plot it, what TQQQ, what the chart looks like, and then we can print the stats here. And so if you look at this, for this first month of 2016, buy and hold return, TQQ pretty much went straight down during this particular time period. And you see we have a return on the strategy of 4%. You know, it's actually up because it's only in the position for a very short amount of time. So just 1 month there, 4%. Now, would you have actually gotten these results in real life if you hooked this up to your live trading account? I don't know. I don't want to tell you to do that. This is just a simulated environment, so I don't know what fills you would have actually gotten in the real world, but in this particular backtest, the way it's written, it results in a 4% return. So the next thing we're going to do here is dynamically adjust our position size depending on the amount of risk we want to take and the amount of cash in our account. And we're also going to code in our exit logic to make it more specific. So we're going to implement a take profit price and calculate a stop loss. And we're going to include that with the actual order that we execute. And so to do that, we're going to use the TP or take profit parameter in Backtesting.py and the SL parameter, the stop loss parameter. And these are both parameters that we pass in when we're executing the order. So when we call the self.buy and self.sell, we're gonna pass those in. So this is the code for it, and I have it in the notebook, and we will discuss it. Up here, I've added a couple of new variables called risk percent. So we want to risk up to 1% of our account balance. Then we have this take profit multiple, and we're going to use that for our stop loss. In our next function here, all of this beginning logic is the same. We're just calculating the opening range. That's not going to change. Now, when we get to the self.buy and self.sell that we just wrote, we're going to change this to actually implement a take profit price and a stop loss price and dynamically calculate the position size. And so rather than a fixed position size, we're going to use a formula. So let's start with the take profit price and the stop loss price. So the take profit price is here. And so we calculate that as our planned entry price plus some multiple of the size of the opening range. And so here I calculate the range size, and that's just the opening range high minus the opening range low. And then the multiple that we have up here, our take profit multiple is 10. We can configure that. Maybe you want 5 times the opening range to be your profit target, for instance. So we take our planned entry price, right? So our planned entry price is the close of this 5 minutes, right? And why do I call it a planned entry price? Because we don't actually know the entry price yet. It's not going to fill until the next bar. We don't want to have any look-ahead bias where we look and assume what our entry price is going to be after the 5 minute bar. So all we know is the close of the first 5 minutes, and then we're going to plan an entry and use that for risk calculation right here. So we're not assuming it's going to fill at that price. So our planned entry price is the close, and then we're going to add 10 times the range size, and that's going to be our take profit price, right? And so that's an order that's going to happen sometime in the future, if it even gets there, okay? Likewise, on the short side, our take profit price is going to be our planned entry price, again, the close of the bar, and it's going to be minus. So minus 10 times the opening range will be our take profit price if we're going short. And so in Backtesting.py, we just pass that take profit price to self.buy or self.sell using this TP parameter, and it'll handle that for us. Likewise, we need to set a stop loss. Now on our stop loss, we're not doing 10 times the opening range. We're keeping our stop loss really tight here. And so if we're going long, so if we're saying we broke out above the opening range, we're going to set our stop loss at the price of the opening range low. So we set stop loss price to opening range low, and we pass it in as the SL parameter right here. If we're going short, we set our stop loss price to the opening range high. So we don't want the price to go higher than that, or we need to exit the position. And we pass that to the SL parameter. So we're queuing up market orders now that are going to fill on the open of the next bar. And we've specified what our take profit price is and our stop loss prices are. And those are going to be different depending on whether we're going long or going short. And so we're going to enter a position. Now the day is going to continue and continue on, and eventually either we're going to hit that take profit price and take our profits, or we'll hit the stop loss and be taken out of our position. But we might not hit either one of them. Maybe it just kind of stays around the same price. And in that case, all the minutes will pass until the end of the day. And if we're still in the position and we hit our exit minute bar, we're going to go ahead and close out the position at the end of the day, take our profits or losses, whatever we have. We're going to close it out, and we start a new day fresh once again. So the last thing we'll do here is add this margin parameter. So if you click on this, you can look at the backtesting documentation here, and you see there's this parameter called margin that's set to 1.0 by default. But if you look at the docs here, this is the required margin of a leveraged account. To run the backtest using 50-to-1 leverage that your broker allows, set the margin to 0.02. And in this case, they said we want to use 4, so we'll do 0.25. And so in the code here, I've set the margin parameter here to 0.25. The other thing we'll do here is they have a commission parameter. If this by default is 0, we don't want to do 0 fees. And so what this does, you can either send in an actual value here, or you can send in a callable function here. And so this commission will be a function of your order size. And so if you look at the code here, I've added a per share commission function here, and that is the absolute value of the size. Absolute value because if you're going short, it's a negative value. And so you multiply that number times 0.0005, and that's your commission. And then you pass that to the backtest object up here. The other thing I've done here is take the formula from the paper and add it to a get position size function here. And so all it does is receive our entry price and our stop price and calculates the number of shares to buy based on our risk percentage and the size of our account. And one more finishing touch here. This is kind of ugly. There's some early close dates to take into account. There's probably an elegant way to do this with like a Pandas market calendar or something. But you'll notice around the holidays, you'll know if you trade that, around Thanksgiving, Christmas, 4th of July, and the United States holidays, that the market will sometimes close a few hours early. And so in that particular case, my exit minute of 1559 is not going to be accurate. And so there's some days when I was looking through the detailed trades where my position wasn't closing, and I wasn't sure why. And so those days the market's closed early. And so I added these early close dates. And so we have this position closing logic where I say if it's the exit minute bar or the current bar's date time is in one of these early close dates, then we'll close the position. And that ensures that I close all of the positions right there. And so at this point, we can run the strategy, and I just let it run all the way through, so you can comment out that bit where we filter down the dates, and you can run this all the way through to see the results, and you can output all of the trades. And so down here, after it finishes, what I do is output all those trades to a CSV file so that I can compare them with the results of the paper from Concretum. All right, so eventually that finishes, and you can see the stats here. So when you run bt.run, it returns this stats object here, or data frame, and then you can, or I think it's a series, Pandas series, that you can print out. You see the start and end of the backtest. You see, indeed, our results are over 1,000% return. Believe it or not, this buy and hold return is inaccurate here. So if you look, obviously, TQQ was way up over the time period. That's because they have this unadjusted data set. And so TQQ has actually split several times over the course of this period, as you can see right here on this price data when it's plotted out. But it doesn't matter in this particular case because this is an intraday strategy. So we're entering at the 5-minute timestamp and then closing at the end of the day. So splits aren't really affecting our outcome here. Just know that the buy and hold return is very positive during this period. And so I wanted to see if my results here match what were in the paper. You see I have a win rate of 25% here. The paper had 24%. The paper had 1,795 trades. I had only 1,580 trades during this period. But I got the trade details here that you can download. So I output those to a CSV at the end of the day. And so that's this line right here. And so what I did here is compare the entries and exits. And so I have theirs on the left here. So January 5th, they went short, entry price 108.08, stop price 108.83. And you see mine, I have entry price 108.08, and then I have a stop loss of 108.93. Likewise, next day 101.23, and the stop price 184. 101.23, 184, and then I have the reasons, so you can look at the exit price and so forth, and then see all of the different trades that were being placed. So if you compare their version versus my version and the trade logs, you'll notice the entry and the exit prices planned are the same, but there's a few days where I attempted to enter the trade, but I actually didn't get a fill due to the way I do my position sizing and my planned entry price. So you'll see January 26th, then January 28th. I wasn't able to get a fill on January 27th, whereas they were actually able to get a fill on January 27th. And that's because I used this planned entry price here. So remember, Backtesting.py will queue the order, right? But it doesn't fill to the open of the next bar. And so the way they had their position sizing and risk logic coded, they use the entry price as the open of the next bar. But I don't know the open of the next bar yet, so I couldn't use that. So I just had a planned entry price rather than an entry price, and then I let it fill if it could, right? So I used their same calculation, but there's a slightly different entry price used for the position sizing, if that makes sense. Now, I could have waited until the open of the next bar and then queued the trade then, but then I wouldn't actually got the trade filled until the next bar after that in Backtesting.py. So there's a slight compromise made there. However, the results are actually fairly similar there. And just wrapping up, I just wanted to say my first impressions of Backtesting.py were very favorable. First time I've used the library, I like that it was very small and lightweight, so there aren't a ton of different objects. So unlike QuantConnect, it's very powerful, but it also can have a steep learning curve. There's like 5 different objects with a few attributes, and that's it, and that's all you need. And so that's great, but there's a couple limitations there. The first is you notice I'm just trading on one symbol. So as far as I know, you can't do these multi-symbol strategies where they share an account balance and do like sector rotation or a basket of stocks or anything like that. You're just running one backtest on one symbol at a time. And then secondly, unlike something like Backtrader, there's no support for live trading. So I have this nice backtest and it's pretty graph, but it's not like I can just click a button, connect it to my trading account, and have it start trading. So Backtrader and QuantConnect, you can do this. And I'll also mention I'm kind of working on my own backtesting and live trading engine as well that I may talk about in the future, but who knows if I'll ever actually finish. So no promises there. Yeah, that's it on backtesting for now. Let me know if there's any other papers like this you would like me to look at. I thought that was pretty fun. I did mention they have a follow-up paper called Day Trading Profitable, what's it called? Stocks in Play. Concretum, right? So they do have a follow-up that's not just TQQQ. This one is a little bit different, and it uses a basket of 20 stocks, which is cool. And this one, I actually probably couldn't use Backtesting.py. I'd have to write a custom backtest for this, but I thought this one was pretty cool because it's not just limited to one symbol that we know performed well ahead of time. So this one might be more interesting. Anyway, let me know if you find that interesting or what else you want to see. I'm going to code up. I'm going to release another video on a live trading version of this that hooks to a brokerage account. And yeah, see you in the next video. Bye.